Welcome to lesson 10.1.2 on arcs and angles in a circle. An arc is a part of a circle. Every central angle has a corresponding arc. For example, this is my central angle here, and its corresponding arc is SU. Since the measure of angle helps us know it's part of the whole 360-degree circle, an arc can also be measured in degrees, representing the fraction of the entire circle. The measure of the arc is defined to be equal to the measure of the corresponding central angle. I can identify a central angle by an angle whose vertex is at the center of the circle. Examine the circle above. What is the measure of arc SU, written as such? I know that that measure has to be 40 degrees because its corresponding central angle is 40 degrees. If I want the measure of SZU, that would be the arc starting at S going through Z on its way to U, and that would be 360 minus the 40 degrees that I know the other arc is, would be 320 degrees. Because that arc is more than 180 degrees, it is called a major arc, while SU is called a minor arc, as it is less than 180 degrees. If an arc is equal to 180 degrees, it is called a semicircle. So in summary, a central angle, whatever the measure of the central angle is, its corresponding arc always has the same measure. The other type of angle we're going to talk about in this video is an inscribed angle. An inscribed angle is an angle whose vertex is on the circle. Central angle was in the center, and an inscribed angle has the vertex actually on the opposite edge of the circle. The inscribed angle has an intercepted arc that is formed by where the two rays of the angle meet the circle. And the relationship here is that the inscribed angle, that is angle X, is half of its intercepted arc. You may see that play out in something similar to the problem that I've drawn here, where maybe you're asked to find the measure of arc AB. In this case, because this is the inscribed angle, the measure of arc AB is going to be double that, or 80 degrees. And then there's one more piece of information that we're going to commonly see that I want to go over with you, and then we'll practice some problems together. Let's say this arc here is 100 degrees. How are X and Y related to each other? If I look at this, Y, if I extend the sides of angle Y, I see that that intercepts this 100-degree arc. So I know Y has to be half of 100 degrees. But X also intercepts that same arc. If I trace the angle or the sides of the angle that form angle X, I see that that is also intercepting that same arc. So that has to be 50 degrees. When you have a circle and you have two angles that both intercept the same arc, in this case, they would intercept this arc right here. These two angles would be congruent to each other because they'd both be half of that intercepted arc given in red. All right, let's practice this. I'll do the first couple, and then I'm going to have you pause the video and input your answers in a minute here. So remember, there's two types of angles. There's a central angle whose arc is the same as the measure of the central angle, and then there's an inscribed angle whose measure is half of that intercepted arc. We're going to use these relationships to help us solve. So looking at this one, X is the inscribed angle here. So I know X is half of its intercepted arc, which is 118 degrees, or X is 59. Looking at part B, again, I have this inscribed angle relationship. So x, this time, is the arc. Well, I know the arc is double the angle measure if it is an inscribed angle. Looking at part C, I now have 3 variables. I have a triangle in here. I have a little bit more going on. One thing that's really helpful is to take a minute and highlight the edges of the inscribed angle because it allows you to see the intercepted arc a little more clearly. Looking at this intercepted arc, y has to be double the 78 degrees. And then let's see, what else do I know? Oh, well, this is a triangle. So I know that these 3 angles, the 90, the 78, and the question mark, have to be equal to 180, so I can solve for that missing angle. When I go ahead and subtract those, I find out that that angle is 12 degrees. So then if I trace that angle to find its intercepted arc, I know that z now has to be double the 12 degrees. And because this line that I have here cuts through the center of the circle, I know that this is a diameter. It cuts the circle in half. So I know x has to be 180 degrees. This would be 24, and this would be 156. If I check them, all 3 of them together should add up to 360, and they do. Another way that I could solve for x would simply be to look at the angle that creates that arc. Now, when I look at this angle, I see that this arc has to be intercepted by that angle, so that arc has to be double the 90-degree angle, so I could also take 2 times 90 there and also get 180 degrees. All right, step 1 for you, I want you to go through and tell me what is x in this diagram. Okay, once you realize that x is 56 degrees, I should be able to use my inscribed angle to find the value of y. Moving on to E, again, find x. Good, x should be 114, and then y. When I look at extending the sides that make y, I see that y is an inscribed angle, so I know it has to be half of 114. And then again, I'm going to start by finding x. It may be helpful to trace the inscribed angles. And then once I find x, I'm going to take a minute and solve for y, again tracing those inscribed angles. May be helpful to see what arcs and angles go together. All right, you made it. Hopefully this was helpful for you. We will continue to have more practice for you in class. You can always rewatch this video as many times as you need to get a little bit more practice and review these concepts. Thanks for watching.